Guys, welcome back to my channel. So before we start with our math lesson for today, please don't forget to hit the subscribe button and the notification bell for more videos. Okay? So by the way, Teacher Dong will discuss to you today the second type of sequence, which is geometric sequences and geometric series. So we're done now with the arithmetic sequences in the previous video. This time we're going to talk about geometric sequences and geometric series, and we will also differentiate the two types of sequences. So before we start, let us first define what is geometric sequence. So when we say geometric sequence, guys, if arithmetic sequences are formed by addition, so that's the operation for arithmetic sequences, geometric sequences are formed by multiplication. So each term in a geometric sequence is found by multiplying the previous term by the same number. So what do we mean by that? If in arithmetic sequence we are adding to the next term of the sequence to get the next term of the sequence, in geometric sequence we are actually multiplying to get the next terms of the sequence. So the operation now is multiplication. But if in arithmetic sequence we are using common difference to get the next term, and then common difference is being acquired by subtracting from right to left, in geometric sequence we are using common ratio. What is common ratio? Common ratio, the constant multiplier in geometric sequence, it is denoted by the letter R. So we are going to use the letter R as a symbol for common ratio. How are we going to get the common ratio? So you are going to get the common ratio by dividing. Let's say, for example, we have the geometric sequence 2, 8, 16, 32, and 64. Okay, so how are we going to get the common ratio? So we can get the common ratio by dividing. Let's say, for example, 64 divided by 32 is 2, 32 divided by 16 is 2, 16 divided by 8 is 2, 8 divided by 2 is 2. So let's change this to 4. So if we're going to take note of this one, the common ratio is 2. So to get the common ratio that will serve as the constant multiplier to get the next term, we need to divide from right to left, regardless if it is fraction, if it is decimal, we don't care about that. For as long as you divided properly from right term, you divided from right going to the left. Right divided by the left. Please don't forget that. Now, types of geometric sequences. So, of course, we also have two types just like arithmetic. We have finite geometric sequence with definite number of terms. So it means that by just looking at the term, by just looking at the sequence rather, you will be seeing if how many terms are there. Like for example, we have 1, 5, 25, 125, 625. So you can count the number of terms. That's what we mean when we say finite. We can count. The terms are countable. The terms of the sequence are countable. Unlike if we say infinite geometric sequence with indefinite number of terms. What do we mean by that? You cannot count the number of terms because the terms are unending and indefinite. Like for example, we are using ellipsis symbol to indicate that this sequence is infinite geometric sequence. Alright, so same as well with the following. We cannot just simply say that there are 5 terms. So there are 5 terms shown, but after the last term indicated, there are still infinite number of terms. That's what we mean by that. Now, in general, geometric sequence is of the form a sub 1 until a sub 1 are raised to the power of n minus 1. So this is now the formula in solving for the indicated term or simply the last term of a sequence. Let's say for example, you are looking for a sub 20, a sub 30, a sub 100, a sub 105, a sub 10, and so on and so forth. We are going to use this formula wherein a sub n is the indicated term that you are solving equals a sub 1, which is the first term, r raised to the power of n minus 1, wherein r is our common ratio and n is our number of terms. Alright? Now, we also have a separate formula for common ratio. So, common ratio now is equal to positive negative n minus 1 root of a sub n over a sub 1. What do we mean by this? You will just divide the indicated term or the last term divided by the first term. That's it. Now, Example 1, write the formula for the nth term of the given geometric sequence. So in this specific example, we just need to solve for the formula, or we just need to write the formula. So given this sequence. Now, to write the formula, we have to write our general term for the geometric sequence, which is a sub n equals a sub 1 r raised to the power of n minus 1. So if that's the case, in writing the formula, we only need a sub 1 and also r. So this formula now is being used to identify the terms of this sequence. Now, how are we going to identify a sub 1? A sub 1, of course, is the first term of the sequence. So in this sequence, we have 32. And then your common ratio, remember, you can divide any two pair from right to left, or any pair from right to left. Like for example, 8 divided by 32, you cannot say that the answer here is 4. Rather, the answer here is 1/4, or simply you can use 0.25 if you would like to make it decimal, or if you would like to use decimal. Now, we can write the formula. So let's say we're going to use the decimal common ratio. It's now a sub n equals a sub 1, which is 32, times 0.25 raised to the power of n minus 1. So the formula for this sequence is now a sub n equals 32 times 0.25 raised to the power of n minus 1. So that's how you will write the formula. Okay? Next, number 2. Write the first 4 terms of the geometric sequence, which nth term is given by a sub n equals 4 times negative 5 raised to the power of n minus 1. So in this case, we just need to write the first 4 terms given the formula or the general term of the sequence. So we will be identifying if what is a sub 1, what is a sub 2, what is a sub 3, and what is a sub 4. So we will be using this formula now. So a sub 1 will be equal to 4 times negative 5, and change n to 1 because we're looking for a sub 1. So this will become 1 minus 1. For a sub 2, it's 4 times negative 5 raised to the power of 2 minus 1. We will be changing n to 2. So then a sub 3 is equal to 4 times negative 5 raised to the power of 3 minus 1. And then a sub 4 is 4 times negative 5 raised to the power of 4 minus 1. So you can already simplify this using your calculators to get the final answer. There's no problem with that. But if you would like to solve for it manually, so it will become 4. Then simplify, following the PEMDAS rule, you need to simplify first the exponential expression. So negative 5 raised to the power of 1 minus 1, it's negative 5 raised to 0. And for all we know, zero law of exponents, when you raise a base to 0 except 0, the answer is always 1. It's not 0. Please don't forget that. So it's now 4 times 1 equals 4. So your a sub 1 is 4. Same thing with this one. You can just simply compute this using your calculator to make your life easier. So it's now negative 20. Here it's 100, while here it's 500, or negative 500. So therefore, the first 4 terms of the sequence are 4, negative 20, 100, then negative 500. So these are your final answers. Teacher, why the signs of the terms are alternating? Let's say this one's positive, negative, positive, negative. It's because of the common ratio. If the common ratio in geometric sequence is negative, remember that the signs of the terms are alternating. Okay, so please don't forget about that. So if it is negative, okay, so the signs are alternating. We were able to identify the 4 terms because of the general formula or general term. Next, number 3, find the 8th term of the geometric sequence 48, 24, 12, 6, 3, and so on. So we are just looking for a sub 8. And of course, with the guide of our general term, a sub n equals a sub 1 r raised to the power of n minus 1. Then we need the following values. Your a sub 1 is 48. So your common ratio, divide 3 divided by 6, or 6 divided by 12, it's up to you. It's 0.5, or 1/2 if you want. Next, n, we are looking for a sub 8, therefore your n is 8. Now we can substitute to the formula. So 48 is the first term times the common ratio, 0.5 raised to the power of 8 minus 1. Then 48 equals 0.5 raised to the power of 7. Now you can simplify it using your calculators to make to cut the process. It's also okay if you will be using your calculators in writing everything and getting the answer. So in this case, our answer is 3 over 8, but if you answered decimal, which is 0.375, it's also correct. Therefore, your a sub 8 is 3/8 or 0.375. Next, find the first term of the geometric sequence, which fourth term is negative 40, and the common ratio is negative 2. Okay, so the unknown value is not the indicated term, because the indicated term is already given, which is a sub 4 equals negative 40. So therefore, we are looking for a sub 1. So that's the unknown value. Of course, we will be using the same formula. A sub n equals a sub 1 r raised to the power of n minus 1, wherein your a sub 1, of course, is unknown. That's the one that we're going to look for. And your a sub 4, which is the indicated term or last term, is negative 40. Your common ratio is also given, which is negative 2, and your n, of course, is 4. Now, let us substitute to the formula a sub 1. Okay, so it's unknown, therefore we will solve it. Your a sub n, or the last term, is negative 40 equals your a sub 1, which is unknown, and your common ratio is negative 2 raised to the power of 4 minus 1. So let us simplify this. Negative 40 equals a sub 1 times negative 2 raised to the power of 3, or cube. Then let us simplify that. Negative 2 cube, negative 2 times negative 2 times negative 2 is negative 8. And then we divide both sides by negative 8 to solve for a sub 1. Therefore, your a sub 1 is 5. Because negative 40 divided by negative 8, negative divided by negative is positive, positive 5. Alright, let's proceed. In the sequence 3, 6, 12, 24, which term is 3072? So in this case, guys, we will be solving if which term. The last term or the indicated term is given, which is 3072. All we need to solve is the value of n. That's the unknown. Okay, with the guide of our formula, a sub n equals a sub 1 r raised to the power of n minus 1. So we will be identifying the following values in solving. Your a sub 1 is, of course, the first term, which is 3. Your common ratio, divide 6 divided by 3, it is 2. And your n is unknown. Okay, so but we will be looking on the last term, which is given, a sub n equals 3072. So this one. Then we can substitute to the formula a sub n, which is 3072, equals your a sub 1, which is 3. Your common ratio of 2 raised to the power of n minus 1, n is unknown. Now, we will be simplifying. You cannot just simply multiply 3 and 2 raised to the power of n minus 1 because they are dissimilar. Okay? Now, what we can do is divide both sides by 3 to eliminate 3. Right? So, 3072 divided by 3 is 1024. And then, okay, so we cannot easily simplify this because this one is what we call exponential equation. Now, in exponential equation, we can just simplify the exponents if and only if the bases are the same. In this case, this is 2, that's the lowest base, and then this one is the higher base, which is 1024. All we need to do here is to make the two bases similar. So it means we will be making 1024 2. How? We will be factoring it. Okay, so until we reach 1024 by multiplying. 2 times 2 is 4, times 2 is 8, times 2 is 16, and then times 2 is 32, times 2 is 64, times 2 is 100. Okay, so 64 times 2 is 128, times 2, 256, times 2, 512, and then times 2 is 1024. And then you count 2, 4, 6, 8, 10. So there are 10 factors of 1024. Okay, then count, we have 10. So 2 raised to the power of n minus 1 equals 2 raised to the 10 power. That's how you will make it. As you can see, the bases are equal. So we can now simplify this n minus 1, just remove the exponents and use them. N minus 1 equals 10, and therefore addition property of equality, 10, opposite of negative 1 is 1. So therefore, the answer is 11. Which term is 3,072? It's the 11th term of the sequence. So if you are looking for the value of n, guys, please don't forget to follow this process. Okay? Please don't forget to follow this process in solving for the value of 10 or the number of terms. Okay? Now we're done with the solving for indicated term, a sub 1 and n. Let's have now geometric series. Of course, when we're talking about series, we are pertaining to the sum of the terms. Geometric series means it's the indicated sum of the geometric sequence. Okay, so we will just be talking about finite geometric series. The sum S sub n of the first n terms of a geometric sequence is S sub n equals a sub 1, quantity 1 minus r raised to the power of n over 1 minus r. So to solve for the sum of finite geometric series, we will just be using this formula. So where a sub 1 is the first term, r is the common ratio, and r must not be equal to 1 because it will make the sequence or the answer 0. Alright, so please don't forget this formula to solve for the sum of the n terms. It's a sub 1, quantity 1 minus r raised to the power of n over 1 minus r. Now let's solve this. Example 6, find the sum of the first 12 terms of the geometric sequence 3, negative 9, 27, negative 81, and 243, so on. Okay, so we are looking for S sub 12. So to solve for S sub 12, of course, we will be using the formula S sub n equals a sub 1, quantity 1 minus r raised to the power of n over 1 minus r. Then we need the following values. Your a sub 1 is the first term, 3. Your common ratio, negative 9 divided by 3 is negative 3. And your, of course, your n is 12 since we're looking for S sub 12. Now we can substitute to the formula. Your a sub 1 will be 3 times 1 minus r, the common ratio is 3, negative 3, raised to the power of 12 over 1 minus negative 3. Now to solve it faster, simplify first using PEMDAS. Okay, simplify first the terms inside the parenthesis. 1 minus negative 3 raised to the 12 power. Okay, so it's now 3 times, what's the answer? Okay, so it's negative 531,430. You can use your calculator in simplifying. Then 1 minus negative 3 is positive 4. Then the next thing is we will be multiplying 3 times negative 531,440. So you will be getting negative 1,594,320. Then divide by 4. So the final answer, or S sub 12 now, will be negative 398,580. So this will serve as your final answer. That's how you will solve for the sum. You are going to follow the formula for you to be able to compute for the sum of the terms. Okay, for geometric series. Now let's have the same example with different values, of course. Find the sum of the S sub 9 of the geometric sequence 4, 12, 36, and 108, and so on. Now, we are solving for S sub 9. Of course, we will be using the formula S sub n equals a sub 1, quantity 1 minus r raised to the power of n over 1 minus r. Then, to solve for S sub 9, of course, we need the following values. Your a sub 1 is 4. Common ratio 4 divided by 12 is 3. And our n, of course, is 9. So, substitute to the formula. Your a sub 1 is 4 times, or quantity 1 minus 3 raised to the power of 9 over 1 minus 3. So, simplify this first, the one inside, okay, for you to easily solve this. So, therefore, we have 4 times negative 19,682 over 1 minus 3 is negative 2. Okay, so the next thing that we're going to do is to multiply the numerators. 4 times negative 19,682. Okay, so it's negative 78,728 over negative 2. Now divide by negative 2. The final answer will be as of 9 equals 39,364. This will serve as your final answer. So take note that we just simply follow the process. We used the formula, and then after that we simplified. Okay? Next, we have geometric means. Of course, when we say geometric means, these are the terms within the sequence. Okay? Now, there are two ways to compute. If you are only looking for the single mean, let's say for example, your a sub 1 is given, and then we are just looking for single mean, then this one is a sub 3. You can use the formula square root of a sub 1 times a sub 3. But if you are solving for more than one means, okay, two or more means, this one is the process. Okay, solve for the common ratio using the formula positive, negative, n minus 1 root of a sub n over a sub 1. So solve for this or for the common ratio, then that's the time that you will be able to solve for the means. Okay, so there are two ways if you are only looking for one mean. Okay, so just simply use this formula, and then if you are looking for more than one or two or more means, okay, solve first for the common ratio. Then let's have the following examples under geometric means. So solve the following. Letter A, insert two geometric means between 7 and 875. Okay, so let's compute for the two means. So this will be the sequence 7, and then we are looking for two means, then this one is 875. Okay, now to solve, of course, we need the common ratio, positive, negative, n minus 1 root square root of a sub n over a sub 1. So to solve for the common ratio, now we have four terms, 1, 2, 3, 4. Okay, substitute. R equals positive, negative 4 minus 1. Your last term is of course 875 over your a sub 1, which is 7. Then the next thing is, let us simplify this, equals positive, negative cube root of 875 over 7 is 125. And cube root of 125 is positive, negative 5. So this will serve as your common ratio. Now we can solve for the means. Okay, so mean sub 1. To solve for mean sub 1, multiply the first term times the common ratio of 5. So 7 times 5 is positive, negative 35. Okay, and then for the mean sub 2, it's now 35 of course, which is the second term, times the common ratio, positive, negative 5. The answer is positive, negative 175. Therefore, your means are 35 and 175, or we can say that since if the common ratio is negative, the signs will be alternating. We have 35 and 175, or negative 35, positive 175. So either of the two is correct. Okay, so why did we have this kind of answers? Because the common ratio is positive and negative. The common ratio is either positive and negative because we extracted the roots. Now let's have letter B. Find the geometric mean between 7 and 63. So this one is very easy. We can use the simple formula to solve for m sub 1, or this m sub 1 is also the a sub 2. Okay, so positive, negative square root of a sub 1 times a sub 3, or the last term. Okay, substitute the values. Positive, negative, your a sub 1 is 7 times your a sub 3. We can simply use this formula because we are only looking for one mean, times 63. Okay, so all you need to do is to simplify that for you to be able to get the right answer. Okay, so 7 times 63 is 441. square root of 441. Then square root of 441 is 21. So therefore, your mean is 21. Okay, so this will serve as your final answer. It could be positive 21 and negative 21. That is your answer. Next, let's have problem solving. So problem solving. It's really important to know the different applications of a specific math concept, because if you're going to encounter at first a specific math concept, you will put in your mind, or you will ask yourself, where will I use this? Where will I apply this? So that's why it's really important to actually encounter some real life problems involving this or geometric sequence, which is the second type of sequence that we are discussing right now. So let's have the first problem. A ball is dropped from a height of 300 centimeters, bounce 270 centimeters, and then bounce again by 243 centimeters, and so on. How high will the ball reach after the fourth bounce? So in this specific example, guys, we can see that there is a ball. Now, if you're going to drop the ball, it will stop suddenly because of the effect of gravity. It's because of physics. Alright, so how is this? First thing is you have to write the sequence, 300 centimeters, and then followed by 200 centimeters, then bounce again 243 centimeters. Now we are just looking for a sub 4, and this one is very simple because you don't need to use the formula here, because you can solve by just using the common ratio. So solve for the common ratio. 270 divided by 300 is 0.9. So to solve for a sub 4 now, get the last term indicated, which is 243 times 0.9. Okay, so compute it. 243 times 0.9 is 218.7. Then, since this is a problem solving, don't forget to write the unit of measurement. So, at the fourth bounce, the distance will be 218.7 centimeters. That's already the answer. Okay, so let's have this one. Let's apply it in biology. The number of bacteria in a culture triples every 3 hours. If there were 2 bacteria present at noon one day, how many were there at noon the next day, assuming that all bacteria survive? So in this specific example, we are solving for all. It means the total number of bacteria the next day. So it means we are solving for the sum. Then, of course, we will be using the formula S sub n equals A sub 1, quantity 1 minus R raised to the power of n over 1 minus R. Okay, so your A sub 1 will be 2 bacteria present at noon. So therefore, our A sub 1 is 2. And our common ratio, 3 poles. So this means that we have 3 as the common ratio. And how about our n? Noon this day up to noon next day means we have 24 hours. And then according to the problem, 3 poles every 3 hours. So we need to divide this by 3 to get n, which is 8. So we are solving now for S sub 8. Okay, so this is the unknown. So therefore, S sub 8 is equal to A sub 1, which is 2. Okay, times 1 minus 3 raised to the power of 8 over 1 minus 3. Then simplify. What is 1 minus 3 raised to the power of 8? It is negative 6,560. 6,560 over 1 minus 3 is negative 2. Okay, so 2 times 6,560 is 13,120, or negative 13,120. Divided by negative 2, your answer will be S sub 8 equals 6,560 bacteria. So therefore, the noon next day, you will be having a total of 6,560 bacteria at all. Okay, so that's the application for biology. Now let's have this one, investment. A car depreciates by 2% every year after its acquisition. What is the depreciated value of the car after 3 years if the original cost is 700,000? In this specific problem, we are applying investment. So it means that there are positive investments, there are negative investments. When we say negative investments, the price of the specific commodity depreciates or decreases every year. Okay, so that's what we call depreciation. So it means that in this specific problem, if you will be buying a car, after several years the value goes down. If you would like to solve it, if you would like to sell it rather, you cannot sell it using the original price. So it means that's a negative investment. Okay? So and then let's say for example you will buy a phone, iPhone and so on, other types of phone gadgets. Please put in your mind that when you buy gadgets and phones, every year the price depreciates. Okay, but if you will actually invest, like for example for house and lot, for gold, okay, so the price every year is increasing. That's what we call appreciation. So the price appreciates. Now also, if you're going to act, let's say for example, if this type of problem, the salary of the employees increased by 2% every year, it means that, okay, it's a positive thing because the salaries are increasing. Unlike this specific problem, okay, so we are solving for the price of it after 3 years. So therefore, we are solving for a sub 3 using the formula for the general term. Now, we need the following values. Your a sub 1, of course, is the original price, which is 700,000. And your n, of course, is 3. And then for the common ratio, if it is depreciation or percent of depreciation and appreciation, so before you can get the ratio, you have to compute. For the depreciation, you need the 100% plus the given percent, which is minus rather because it's depreciation, minus 2%. 100% minus 2% is 98%. Convert this to decimal, this will become 0.98. So that will serve as your common ratio, 0.98. But let's say there's an increase of 5% every year. Okay, so that's what we call appreciation or increasing. It's now 100% plus, let's say 5%. So this will become 105%. Convert this to decimal, it will become 1.05. So that's the difference between the two. But this time, since it's depreciation, so we can use 0.98 as the common ratio. Then substitute to the value, to the formula, a sub 3 equals your a sub 1, which is 700,000. And then your common ratio is 0.98 raised to the power of 3 minus 1. If you will be computing it using your calculator, the price of the car after 3 years will be 672,000. So don't forget to put the unit of measurement. 672,280. So this will be the price of the car after 3 years. Okay? So if you will be encountering this type of problem, please make sure to compute properly for the common ratio. Now let's have the last problem. A billionaire decided to celebrate Christmas as a Thanksgiving by donating 1,000 pesos on December 20, 2,000 pesos on December 21, and 4,000 pesos on December 22, and so on through December 25 to the Lingap Kapwa Charity. The donations form geometric series. What is the total amount of donation? So it means that we are looking for the sum. But how many days? From December 20 up to December 25, it's 6 days. So we will be solving for that. And then identify what is a sub 1. So it's 1,000. But because that's the initial donation. And then for the common ratio, 2,000 divided by 1,000 is 2. And your n, of course, is 6. Now we can compute for the sum. S sub 6 equals your a sub 1, which is 1,000. Quantity 1 minus 2 raised to the power of 6 over 1 minus 2. So simplify this. 1 minus 2 raised to the power of 6 is negative 63. 1 minus 2 is negative 1. Then the next thing is 1,000 times negative 63 is negative 63,000 divided by negative 1. S sub 6 will be, how much is the total donation? It's 63,000 pesos. So it means on December 25, the billionaire donated 63,000 pesos. So those are some of the problems that you can actually see geometric sequence, but there are a lot. So for my students, please don't forget to accomplish this activity, which will be submitted on the specific learning management system that we have. Okay, so I thank you so much for I thank you all so much for staying with me with this new math lesson. So thank you so much, and then please don't forget to hit the subscribe button and the notification bell, Teacher Dong, and I wish you a good day. Thank you so much. Bye.